So the next device we're going to look at is an incandescent bulb. This is an example of a nonlinear device because the tungsten filament will heat up as you put current through it, and as a result, its resistance will increase. And so you should be able to see that when you plot voltage versus current this time around. We're going to need the room temperature, which is 73 degrees Fahrenheit. You're going to need to convert that to Celsius. And so the first thing we're going to do is measure the resistance with nothing, with no current through it. So this is the R0 value. I apologize for the sound, but it stabilizes at 5.6 ohms. So that's the baseline resistance of the incandescent bulb. And so it's not a high resistance device by any stretch of the imagination. And so then what you're going to do is reconnect the circuit. And like you did last time. So you're basically putting the light bulb in place of the resistor, and you're going to measure the voltage across it. And so for this, you're going to set up another table, voltage versus current. And you're only going to go between 0 and 7 volts for this. And we'll see how we can do with this. So we're going to keep this at the 200 milliamp circuit, but we don't want to go above 7 volts. So we're going to start with, try to get 1 volt. All right. So we're at 1.00 volts. And you notice we're already getting a little bit of light through. The current, again, this is in milliamps. When you enter it, you're going to want it to be in amperes so that when you're calculating the resistance, you're getting a reading in ohms. So for 1 volt, you have 51.1 or 51.0 amperes. So now let's go to 2. So that's 2.00 volts, 74.5 milliamps. And you can see the bulb has gotten a little bit brighter. So now we're going to go to 3 volts. All right, so that's 3.01 volts. That's 93.6 or 93.7 milliamps. And so that's going to be your third reading. Now we're going to go to 4. Okay, so 4.00 volts, 109.9 milliamps. And you can see the light bulb is getting brighter and brighter. Just about there. Okay, 5.01 volts, 124.8 milliamps. So that's 6.00 volts, 138.2 milliamps. You can see it's getting brighter, but you can also see the current is decreasing, or the current is not going up by as much now as it was at the start of the run. So now we're going to go up to 7 volts. And that's as far as you want to go. You don't want to go above that. All right, so that's 7.02 volts and 150.6 or 0.5, 150.4 amperes, and we'll stop with that. And so I've turned everything down. and you can see the dimness is gone. So you're going to make a plot of delta V versus I. You should not feel the need to put a straight line fit to this. So you're going to calculate the resistance and the temperature for each entry. So keep in mind, you should be able to, if you look at your textbook, there's the table, you should be able to figure out the temperature coefficient of resistance for tungsten, and then use that to figure out the temperature at each step. And your initial temperature is going to be the 73 degrees Celsius, and your original R0 was the original reading on the multimeter. And so you're going to calculate R0 as you go up, or calculate R as you go up from delta V over I. Ohm's law still applies. And then with that value of R, figure out the temperature for each voltage reading, each voltage and current reading. And so you add that column to the table. And again, with Excel, you can do the calculation once and then fill down, and that'll give you your values. And you're also going to calculate uncertainties in each case. And so don't forget to do those as well. How uncertain are your values for the resistance? How uncertain are your values for temperature? So now we're going to move on to part 4.